when we compare electric field lines versus magnetic field lines, okay, similarities, the density of the lines, when I have lines very close to each other, it tells me I have a strong field. If they are spread out, it's a weak field. The arrow gives the direction, pointing out away from the north or away from a positive charge, towards the south magnetic pole, or towards a negative charge. So these are similar. The main difference is the electrical field lines stop on electrical charges. Magnetic field lines do not stop. They loop around, they continue. They go within the magnet. There is no magnetic charge, remember? We can have only magnetic dipoles. And just for notation, remember then when we draw an X, that's representing a magnetic field pointing into the page, or in this case perpendicular to the screen, into the screen. Sometimes we would put it just as an X, sometimes we would put it as an X in the middle of a circle. A dot points to a field that's pointing away from the page, perpendicular to the page, or in this case perpendicular to the screen, and sometimes we put it inside a circle. Okay, another summary. The source of electrical forces is charges. The source of magnetic forces or magnetic fields, both of them, is moving charges. Now, an electrical field acts on an electrical charge. A magnetic field acts only on moving charges. So the source of a magnetic field is a moving charge, but it acts only on moving charges. The magnitude of the electrical force, magnitude, this is absolute value, is Q times E. The magnitude of the magnetic force is QVB sine theta, where theta is the angle between V and B. Remember, that's the magnitude. Now, for the direction, in the case of electrical forces, the electrical force is parallel to E. It's going to be either in the same direction as E if the charge is positive, opposite to E if the charge is negative. Now, in the case of magnetic forces, it is always perpendicular to both the velocity and B. You use the right-hand rule to find it. Remember, the thumb is going to be the direction of V. The fingers are going to be the directions of B, and the force is the direction of the palm. In this case, actually, it is pointing down, so the palm is pushing down. So that's the direction of the force.